İnsan next
Next is also nice.
İnsan sosu.
Well, next is
Kuzambo and welcome to Bhutan e-learning program. So for today I have a chemistry lesson key stage 4 for periodic table on the topic periodic table. Let me start. First of all, let's imagine that, or let's consider that there are two libraries, library 1 and library 2, and library 1 is well arranged systematically, and every book is placed where it should be, and in second, books are here and there. It is not arranged systematically. So if you were a librarian, if you were somebody working there, and if you were asked to pick some book, a particular book, what do you think? From which library, library 1 or library 2, from which library do you think you can pick that particular book very easily? Yes, obviously it will be library 1, because in library 1, if you have just observed, it has been systematically arranged. Everything is categorized very properly. So likewise, or in the similar manner, periodic table also has elements arranged in a systematic manner, in a systematic order. So what is actually periodic table? The systematic tabular classification of elements in increasing order of atomic number is actually periodic table. And if you just observe this periodic table, what you will see or get to say from this table or the chart is you have an element placed in first group, that is lithium. If you just observe lithium, and while moving from left to right, after some time what occur next is sodium, and after that what occurs is potassium, rubidium and cesium and francium. So here what happens is all the elements with the similar properties, with a similar nature, are actually arranged together in a periodic table. Now before I just go in depth on the periodic table, I would also like to talk something about Mendeleev periodic table. So actually this Mendeleev periodic table was put forward in the year that is 1871 by Russian chemist, and his name was Dmitry Mendeleev. And here what he did was, like when he designed this Mendeleev periodic table, the arrangement of elements were based on the atomic weight. If you just compare it with a periodic table, modern periodic table, that is only the difference. You know, like modern periodic table, it was designed, or elements were arranged based on the atomic number, and in Mendeleev periodic table the elements are arranged based on its atomic weight. And you can also see how actually Mendeleev periodic table looked like. In the year that is 1871, Mendeleev published a periodic table, and slowly his periodic table was called as Mendeleev periodic law. And in that law, what it states is that the physical and chemical properties of elements are periodic function of their atomic weight. It states that the physical and chemical properties of elements are periodic function of their atomic weight, which means that the elements with similar physical and chemical properties tends to reoccur, tends to come again and again after some time when elements are arranged based on its atomic weight. And Mendeleev periodic table consists of actually 7 periods and 9 groups. You can see this. It consists of 7 periods, so the horizontal row in a periodic table is called as periods. So the horizontal row that is there in the periodic table is called as periods, and then the vertical column that is present is called as, in a periodic table, is called as groups. So the vertical column present in a periodic table is called as groups. And in modern periodic table there are actually 7 periods and 18 groups, and This modern periodic table was actually put forward by Henry Moseley in the year that is 1913. Unlike Mendeleev periodic table, modern periodic table is totally based on atomic number. Mendeleev periodic table was based on atomic weight, and modern periodic table is based on atomic number. So that's why what we can say is, in modern periodic table, the elements were arranged in such a manner that physical and chemical properties of elements depends on the atomic number, not atomic weight. And that's why modern periodic law states that the physical and chemical properties of elements are periodic function of their atomic number. So this means to say that when elements are arranged in a periodic table, they are arranged in such a way that the physical and chemical properties of elements tend to reoccur, which means periodic function tends to reoccur when they are based on atomic number. Now let's see a short description of modern periodic table. So the elements of group 1, group 2, group 13 till 18 are called as normal elements, and it also has a reason why we actually call it as normal elements. We call these as normal elements because electrons in the valence shell are filled in according to normal rule of filling the electrons, and that's the reason why we call it as normal elements. If we talk about the element in period 2 and 3 are called as typical elements. Why we call it as typical elements is because it summarizes the elements that are present in group 2 and 3 summarizes the property of their respective group. For an example, in group 1 we have sodium. This sodium will actually summarize the property of group 1, and in the group 2 we have magnesium, for instance, and this magnesium will also summarize all the properties of group 2, and that's the reason why we call it as typical elements. In a periodic table, if you just see, the middle portion is called as transition element, and why we call this middle portion as transition element is because there is a shift, there is a change from highly electropositive to highly electronegative element, and that's the reason why we call it as transition element. Again, we also have something called as inner transition element, and if you just look into that chart, periodic table, you will see that elements which actually lies inside the transition element are called as inner transition element, and this includes lanthanoid series and actinoid series. And now let's see some important families of modern periodic table. So first one is the elements which are present in group 1 are usually called as alkali metals. Now why they are called as alkali metal is because they form alkali with water. So that's why elements like lithium, sodium, potassium, rubidium, cesium and francium, they are called as alkali metal. And elements in group 2, they are referred as alkaline earth metal, and why it is referred as alkaline earth metal is because they are usually found on the earth crust in the form of water soluble base. And element in group 11, they are called as coinage metals. Why we call it as coinage metals is because these elements are used in making coins, so we call it as coinage metals. If you compare again, or if you see the elements in group 17, we simply call it as halogen, and halogen in a Greek word, it simply means salt forming. These elements like chlorine, iodine, all these elements which are there in group 17, what they do is they form salt such as sodium chloride, potassium bromide and potassium iodide and so on. The elements that is there in group 18 are called as noble gas, and why we call it as noble gas is because all the elements which are present like helium, neon, argon, krypton, xenon, radon. These are all having very stable electronic configuration, and because of this stable electronic configuration, they do not actually react with other elements, and that's the reason why we call it as noble gas, or we can also call it as inert gas. So characteristics of purids. In a periodic table, there are 7 purids, and in each period it starts with alkali metal and it finishes with the inert gas, except for the first period. So you can see in a second period it starts with lithium. Lithium is what? Alkali metal. And what is neon? Neon is inert gas. So what I mean to say here is each period starts with alkali metal and finishes at inert gas. Likewise, sodium is a alkali metal and argon is a inert gas. So this continues. As we all know that except for the first period, the number of valence electron increases from 1 till 8 as we move from left to right. If you just see in a periodic table, what we can observe is for the first period we have hydrogen and helium. This is exception, whereas in second period and after that what we can see is the valence electron increases from 1 till 8. For example, lithium, it has a valence electron 1, then beryllium, it has valence electron of 2, boron, it has a valence electron of 3, carbon, it has valence electron of 4, nitrogen, it has a valence electron of 5, oxygen likewise it has 6, fluorine it has 7, and then neon it has 8. So what happens is when we move from left to right in a period, the valence electron increases from 1 till 8. Now second is let's talk about number of shell of elements in a period. For example, let's say hydrogen. If you have hydrogen, the number of shell, we can easily find out how many shell it has, and it will also define or it will also describe in which period it lies. For example, if you just take hydrogen, it has electronic configuration which is 1. It has simply one shell, so that's why it lies in first period. Again, if you see helium, likewise helium also just has 2 as an electronic configuration, therefore it has only one shell, so that's why this also lies in first period. Likewise, if you just take another example of silicon, so silicon Si, so it is 2, 8 and then 4. Now if you just see its electronic configuration, here you can note that it has how many shells? It has 3 shells. So that's why it lies in third period. It lies in third period and it has 4, which is valence electron. Now let's see advantage of modern periodic table. So the first advantage is that it is based on atomic number of the elements, and then the second is that it correlates the position of elements with electronic configuration more easily. For an example, if you just take as magnesium, its electronic configuration is 2, 8 and 2. So how many shells does it have? It has 3 shells, so that's why it lies in third period. And how many valence electron does it have? It has 2 valence electron, that's why it lies in second group. That is how we can actually correlate its position of element after comparing its electronic configuration. And third one is we can easily segregate metal and non-metal. Likewise, in modern periodic table, what we can do is we can actually predict the elements or the properties of the elements even before their actual discoveries. The elements or the arrangement of elements is easy to remember and reproduce in a modern periodic table. So these are the advantages of modern periodic table. disadvantage of modern periodic table is that the position of hydrogen is not fixed. Though hydrogen is placed in first period, but then the position actually is not really fixed in a modern periodic table, because hydrogen is non-metal and then it is placed with very highly reactive alkali metals, which is actually not fixed. And second is position of helium. Looking at electronic configuration, helium should be placed in a second group, but it is placed with halogen group, and that is also actually a drawback of modern periodic table, which is still unclear. And the third disadvantage is that the lanthanoids and actinoids are not included in the body of periodic table. Actually, lanthanoids and actinoids which are there should also be inside the periodic table, but it is generally observed that it is outside the periodic table. So that is the third disadvantage of modern periodic table. You can see here, so this is not fixed. It should be actually inside, but it is placed outside. Now, trains in modern periodic table. Let's before we just move into trains in modern periodic table, it is very important to know few words like periodicity. What is periodicity? So periodicity in simple terms means a repetition or the repetition of similar properties of element after certain regular interval of time in a periodic table is called as periodicity. And what actually causes periodicity? The cause of periodicity is because of the same valence shell electronic configuration. So that is actually the cause of periodicity. Like for example, lithium, if you just take an example as lithium, what we can observe is that lithium has an electronic configuration of 2 and 1. And likewise, what we have is sodium. Sodium has electronic configuration 2, 8 and then 1. And what we have is potassium. Potassium has an electronic configuration of 2, 8, 8 and then 1. Now, when you compare this, what is happening here? We have seen this before also. And what is this? These are all actually valence shell. Valence shell. And this is what? Actually electronic configuration. Electronic configuration. So what it has is, or what is the cause of periodicity? Because it has same valence shell electronic configuration. Because it has same valence shell electronic configuration, it causes periodicity. Before I just discuss about valence electron, let's define what is valence electron. The electron that is present in the outermost or the last shell is actually called as valence electron. For example, let's say sodium here again. In this case, this is valence electron. So when you write electronic configuration, the electron which is present in the last shell is actually called as valence electron. And the valence electron also decides the valency of elements. Valence electron also decides the valency of element. What is valency? Valency is simply the combining capacity of element. For an example, if I just say, let's say there is hydrogen. Hydrogen has a valence electron 1. So that's why its valency will be hydrogen, its valency will be 1. And second, let's talk about oxygen. Oxygen, it has electronic configuration that is 2 and 6. Now what we do is, if the valence electron is 1, 2 and 3, we consider it as valency. But if it is 4, 5, 6, 7 and 8, then what we do is we subtract 8 minus valence electron. So that's why here in case of oxygen the valence electron is 6. So 8 minus 6 will give me 2, which is actually what? The valency. Therefore, the valency of hydrogen is 1 and then the valency of oxygen is 2. Now let's see train of valence electron. trains of valence electron across the period and across the or in a group. So in a period or across the period, as we move from left to right in a periodic table, the valence electron increases from 1 till 8. You can just see in a periodic table what happens is, as we move from left to right, the valence electron increases from 1 till 8. So this is clearly shown here. Now what happens in a group? So as we move down, the valence electron of the element tends to remain same due to similar electronic configuration. So if you just see this example of group 2, what we have noticed is that the electronic configuration is similar. Because it has a similar electronic configuration, that's why the valence electron remains same in a group. Okay, atomic size. Now let's see second property, that is atomic size. Now before going into the definition of atomic size, let's see the structure of sodium. So sodium, in the first shell there is 2 electrons, in the second shell there are 8 electrons, in the third shell there are 1 electron. There is 1 electron. So when you say atomic size, it is simply defined as the distance between the center of the nucleus and the outermost shell of an electron. It can be also referred as atomic radius. So when you say atomic size, it is simply the distance between the center of the nucleus and the outermost shell of an atom. So what happens in a period to atomic size? So it is very important to know that when we move from left to right in a periodic table, the atomic size usually or generally goes on decreasing. In the picture, it may seem like it is of same size, but you have to remember that as we move from left to right, the size goes on decreasing. Now, why actually atomic radius or atomic size goes on decreasing when you move from left to right? This is due to, or this is because of the increase in the nuclear charge. Now let's see in a group, what happens in a group. So the atomic radius down the group increases. We have to know that, or it is very much clear if you just draw the structure, you know what happens as we move down in a group. There is addition of shell. So when there is increase in the number of shell, the atomic radius automatically increases. If you just see in the presentation, it is very much clear that atomic size is increasing as I am moving down. Now third property is metallic or electropositive character. What is metallic or electropositive character? It is simply ability of an atom, of an element, to lose electron and form a positive ion is called as metallic character. Again, let me repeat, the ability of an atom, of an element, to lose electron and form a positive ion is called metallic character. So, a very good example can be sodium and magnesium. Sodium loses 1 electron and forms the electropositive ion. In a period, let's see what happens to metallic character. As we move from left to right across the period, as we move from left to right across the period, due to increase in nuclear charge and due to decrease in the atomic size, electropositive character decreases. Again, let me restate here, the metallic character decreases as we move from left to right. Why? This is because there is increase in the nuclear charge and decrease in the atomic size. What happens in a group now? So if you just move down in a group, the metallic character increases, and why it is increasing is because there is increase in the atomic size and decrease in the effect of nuclear charge. And that is the main reason why metallic character as we move down in a group goes on increasing. The fourth property is ionization energy. So what is ionization energy? Before I just define or explain you what is ionization energy, let's simply see the structure of sodium. Sodium has one valence electron. Because it has one valence electron, there is a possibility, or there is a probability, let me say, for sodium atom to lose one electron. So when it loses one electron, what it does is that it forms, or it becomes positively charged. Therefore, ionization energy can be defined as the minimum amount of energy. It is simply, or it is defined as the minimum amount of energy that is required to remove the valence electron from the neutral atom to form isolate ion is called ionization energy. Let me repeat, it is again the minimum amount of energy that is required to remove the valence electron from neutral atom to form ion is called ionization energy. Ionization energy, in other words, can be also called as ionization potential or ionization enthalpy, and it is expressed in the term of kilojoule per mole or kilocalorie per mole or electron volt. And greater the force of attraction, greater the nuclear charge, greater is the value of ionization energy. Now let's see what happens in a period. So when we move from left to right in a periodic table, it is observed that the ionization energy goes on increasing. Why it goes on increasing is due to increase in the nuclear charge. The number of proton is increasing on each step, and there is increase in the nuclear charge, and there is decrease in the atomic size. Because there is increase in the nuclear charge and decrease in the atomic size, ionization energy goes on increasing as we move from left to right in a periodic table. And it is also important to know here that when atomic size is small and nuclear charge is more, the force of attraction between the nucleus and the valence electron increases, and this results in higher ionization energy. Now in a group, what happens in a group? So as we move down in a group, ionization energy decreases. Why it decreases is due to increase in number of shell and decrease in effective nuclear charge. What happens when you move down? Effective nuclear charge decreases, and there is increase in number of shell, which results to decrease in ionization potential as we move down in a group. You can see the examples here. So when you are moving down in a group, for example, hydrogen has only one shell, lithium has 2 shell, sodium has 3 shell, potassium has 4 shell. So what is happening? Number of shell is increasing as we move down, and the distance between the nucleus and then the valence electron is also increasing. So when the distance increases, the effective nuclear charge decreases. So I can say here that because of these factors, all these reasons, as you move down, the ionization energy decreases. And the sixth property is actually electron affinity. Now ionization energy, what is ionization energy? Let's compare. It is simply minimum amount of energy that is required to remove an electron from an isolated atom. Let's say we are removing an atom. It becomes positively charged. And in other case, or in other hand, let's say there is another atom which actually receives that same electron, and when it receives electron, what it does is it releases some kind of energy, and that is actually called as electron affinity. The amount of energy released when neutral atom accepts an extra electron to form negative ion is called electron affinity. It is also called as electron gain enthalpy. Now let's see what happens in period and what happens in a group. So in a period, as we move from left to right again, electron affinity, the value of electron affinity increases. Why it increases is because as we move down, we all know that atomic size decreases, or when there is decrease in the atomic size, there is increase in the nuclear charge, And when there is increase in the nuclear charge, because what happens is when atom actually accepts electron, it need to release energy. So more amount of energy needs to be released when the nuclear charge is more. So that's why when we move from left to right in a periodic table, atomic size decreases and nuclear charge increases. This increase in nuclear charge results to actually increase in the electroaffinity. And when the atomic size is small and nuclear charge is more, the force of attraction between again the nucleus and then the electron increases. What happens in a group now? In a period, we know that electron affinity increases when we move from left to right. What happens in a group? Electron affinity decreases due to increase in number of shell and due to increase in effective nuclear charge, or due to decrease in effect of nuclear charge. So I have here activity. In this activity, I would like you all to actually identify the elements from the periodic table. You can identify the elements having largest atomic size. You can also identify elements having largest electroaffinity, elements having lowest ionization enthalpy in group 2, and finally you can identify elements which are in a gaseous form in the room temperature. And I have here second question, and in the second question what you need to do is you need to identify at least two factors which actually influences the periodic property of element in group as well as in period. We have already discussed this, and then I'm sure that you must have already by now identified factors which affects which influences the periodic properties. And that's all for today's lesson on periodic table. Thank you so much for giving your time and energy for this lesson, and have a good day. Thank you.
Next thing.
He's the next sheet.
Next is also less.
He's a so
Next is